Okay, we'll look now at finding y. So this is where you're given dy by dx and we're asked to find y. And just so you know, dy by dx is sometimes called the gradient function. So sometimes you might say in a question, the gradient function is, and you have to recognize that that's dy by dx. So we've got dy by dx, our gradient function, equals 5 plus 3 over x squared. And we're told that when y equals 5, x equals 2, and we'll have to find an expression for y. This bit here sometimes is referred to as the boundary conditions. Okay, so this is where you're given just 1 point on the curve, and it's to help us to find c. So to get y, we integrate dy by dx. So put this in the form that we want to integrate by moving the x squared up to be x to the minus 2. Integrate, we get 5x plus 3x to the minus 1 over minus 1 plus c. So that's y equals 5x minus 3 over x plus c. Now we're told that when y is 5, x is 2, so we can use these boundary conditions to find c. So when y is 5, x is 2, so put that into our expression for y. So we've got 5 equals 5 times 2 minus 3 over 2 plus c. So 5 equals 10 minus 3 over 2 plus c. Rearrange that and you get that c is minus 7 over 2 just by solving that equation. And then we can write our equation for y. So remember to write the equation at the end. So y equals 5x minus 3 over x minus 7 over 2. Second example then, our gradient function dy by dx is x squared plus 6x plus 1. We're given our boundary conditions here. When x is minus 2, y is 8, and we have to find y. So y is the integral of our gradient function. So we get x cubed over 3 plus 6, add 1 to the index, divide by the new index. So 6x squared over 2 plus x plus c. So we can tidy that up. So we get y equals x cubed over 3 plus 3x squared plus x plus c. Now we're going to use these boundary conditions. So when y is 8, x is minus 2. So put that into our equation. Just be careful of your minus signs. So that's 8. That'll be minus 8 over 3. That'll be 3 times 4. So we've got 12 minus 2 plus c. And when you work that out, you get c is 2/3. So therefore our equation is y equals x cubed over 3 plus 3x squared plus x plus 2/3. Third one now, just slightly more complicated. dy by dx, a gradient function, equals ax plus b. And this time it tells us the curve y passes through these 3 points, 0, 2, 1, 3, and 2, 2. Find the equation of the curve. So we're going to need to find what a and b equal as well. So the first thing we'll do is integrate. And we get that y equals ax squared over 2 plus bx plus c. Then we're going to use our different boundary conditions or different coordinates here to find our a, b, and c. So if you use 0, 2, first of all, well, the y value is 2. That's going to give you a over 2 times nothing plus b times 0 plus c, which gives you that c is 2. So now we've got y equals ax squared over 2 plus bx plus 2. Now look at the point 1, 3 and put that into our equation. So we'll have 3 equals a over 2 times 1 plus b times 1 plus 2. I'm just going to bring that 2 over and we'll get 1 equals a over 2 plus b. Then put in 2, 2. So when y is 2, we get a over 2 times 2 squared, which is 4, plus b times 2 plus 2. So we get 2 equals 2a plus 2b plus 2. Bring that 2 across and we get 0 equals 2a plus 2b. Now we're simultaneous equations, so it's up to you how you solve these equations. I said, well, that means that 2a has to equal minus 2b, so a equals minus b, and I'm going to substitute that in to our top equation. So our top equation is 1 equals a over 2 plus b, and we've said that a equals minus b, so we can say 1 equals minus b over 2 plus b, so that's 1 equals a half b, so that means b is 2, and therefore a is minus b, so it's minus 2. So putting all that into our equation, we have y equals minus x squared plus 2x plus 2. Remember, our equation was y equals a x squared over 2 plus bx plus 2. So putting in our values for a and b, we get our equation there.